Hey gang, welcome back to Inverted Pursuits Laboratory. And this week we're going to be taking a look at the Screwball rocket. Now, when you get the Screwball rocket, it comes in a kit. You can buy this kit from Inverted Pursuits Laboratory. There's a link in the description below as to where you can pick up one of these. When you open your kit, you will find a baggie of hardware. There's 2 eye bolts, 4 nuts, and 4 washers inside this baggie. There is a phenolic 38mm motor mount tube and the various 3D printed parts you need to assemble the rocket. So let's get these all out and I will show you what we have. Alright. So once you've got everything out of the rocket, you have your fin can, your tail cone or motor retainer. You have the nose cone upper, nose cone lower, and packed usually inside the nose cone will be your nose cone retention / electronics bay. So it pulls out and there's a space to mount a tracker or some electronics. There are also holes in the base of that nose cone retention for where one of your eye bolts mounts inside that hole, as well as some holes for getting electronic wires out if you're doing dual deploy. There are 2 sections that I call body section 1. They are internally threaded and externally threaded on both sides. Then there is body section 2 that has a smooth bore on one side and external threads on the other. Finally, we have the motor tube. So we have the bottom motor tube and then the top of the motor tube, and it's also your other shock cord mount connection point. These 2 pieces simply screw together via the threads located on them. Now, before you screw them together, you will want to attach your eye bolt. Your eye bolt attaches to this piece with 2 nuts and 2 washers. So when you get out your eye bolt, you'll put 1 nut on there where you want it, toss on a washer, slide it through, put another washer on the inside, and tighten the whole assembly together so that it looks something like that. This is now where you can mount your shock cord to quite efficiently and continue building from there. Now we screw these 2 parts back together. This ability for this to come apart makes it very easy if your motor were to get stuck in there, but it comes apart very easily. This phenolic tube is basically our motor liner. So it goes inside the 3D printed part and is what keeps the motor heat from melting any parts of our rocket. So now that's your assembled motor tube, and we can set that aside. Let's take a look at the nose cone real quick. So the nose cone upper is a much heavier, much denser piece. This is part of your CG offset. And I have it set correctly in the OpenRocket files that are available. There will be a link to those OpenRocket files in the description below, where you can download them. But the rocket is in there as it sits. With all of these parts, the CG and CP are as they sit. You can add additional payloads for your nose cone electronics bay, or if you were to add more weights up in the nose, you can add that there as well. Within the nose, I forgot to mention, there is a hole in the base of the nose cone upper where a 1/4-20 bolt can screw into, where you can add washer stacks to move the CG of your rocket further forward if you were to be flying on a larger motor. So the nose cone simply screws together. The electronics base screws into the base of the nose cone. This is also our motor retention. So the other nut and washer set we have goes on here. So you don't actually need one of the 4 washers you have. You only need 3 of them. One is actually just a spare, but you thread that down, washer goes on here. The other nut goes actually inside your nose cone retention and is held in place just by friction. And then you screw, as I drop everything, you screw this into the bottom of your nose cone retention to help attach that shock cord mount. So it screws right on in, and just like that, it is attached. So you want to make sure then you tighten the nut and everything up against it and get everything nice and tightened down so it's where you want it to be. and then this screws right back into your nose cone, and the entire nose cone is assembled. So we can set that aside, and let's take a look at the main rocket body. So the entire rocket body goes together with the fin can, our body section 1s, and body section 2. The two body section 1 pieces screw into each other. The body section 2 screws into the top of the body section 1, just pretty standard male to female threads here. Now, the nice part about this being able to screw together is if you wanted to delete one of these body tube sections, you very easily could. From there, the fin can section screws on to the rest of the rocket body. And you want to tighten everything down, and you've got an assembled rocket body. From here, the next step is actually to insert your motor tube. So the motor tube slides into the back of the rocket. This is removable for maintenance purposes so that you can easily get your motor out. Attach shock cords. If you were to thread your shock cord through the entire length of the rocket, now it comes out the back, you can clip your shock cord on, and the entire thing slides back inside the rocket. Your tail cone motor retention screws onto the back, and it is designed for a 38 millimeter reusable or disposable motor. Specifically, it's mostly designed for Aerotech casings, so those sit perfectly in the back of the rocket. The nose cone then would attach to the other end of your shock cord, and then you would pack the parachute and shove that all inside here. Should be noted that shock cord and parachute are not included with this kit and are something that you need to provide yourself. I recommend 1/4 inch Kevlar and a 24 to 36 inch chute for the rocket. You could even go as high as 48, but you want to check within your open rocket simulation, mess with the parachute, make sure you're coming down at a good ground touch speed, because if you do come down too fast, you will crack the body in half at one of the threaded points. Now, if you were to crack any point of the threads on this rocket, these are very easily fixed with CA glue. I have done this on several of these rockets so far, where I will crack one of these joints and I'll simply thread it back out, glue the threads, just glue the threads back to the body tube. I won't just glue the body tubes to each other, because I want to try and maintain the functionality of taking it apart. So I'll glue the threaded section I broke off back to the body tube, let the whole thing set up, and I've put it back together and flown it again, and it's worked just fine. It does have a tendency towards future failure, but if you really want to make sure this whole thing never comes apart, a couple dabs of CA glue around, and the whole thing will never come apart, and it can just CA glue back together. The entire rocket is printed out of PETG, so CA glue solvent welds the rocket together. From there, the nose cone goes in the end, and you have a completed rocket with all of your hardware inside. So definitely be sure you check your open rocket file. Also, another thing you'll need to do before you can fly is you need to install rail buttons. There is one rail button hole at the bottom of the rocket on the fin can here. The other one goes usually in this body tube section and is something you will have to drill yourself. This will hold up just fine drilling through. You may want to get a longer screw than what comes with your rail button to push it all the way through there. But figure out where your CG point is with your open rocket file, and then that's where you want to drill your hole. If you're trying to figure out how to align the two of them, I recommend taking a piece of string, wrapping it around a bolt in the rail button slot back here, tape the other piece lined up with the tip of the nose cone, and it creates a perfect line down your rocket. And then you just have to measure from the tail of your rocket to where it needs to go, mark it, and you can drill the hole and screw it on. You also have the option to add shear pins to the top of this rocket body if you were concerned about it needing help blowing apart. Adding those shear pins does mess with your threads in the nose cone retention though, and you will have to drill the retention points into the nose cone, but they are there for you to add. There is also a vent port in the side of the top of the rocket so that the pressure equalizes throughout. If you're needing to add a pressure hole because you're putting flight electronics into your nose cone, you will need to drill probably a 1/4 inch or a 3/16 inch hole in the nose cone section. That way the pressure vents properly. You also probably need to add a hole for your switch to turn your electronics on and off. So there are some of the basic features of this rocket. Now, if you say wanted to fly it in a different configuration, it is just as simple as screwing it apart and removing a section, or if you wanted to buy a second section, you could increase the length of this rocket any way you wanted to. Now, an issue I've run into before with this rocket, and one of the reasons I love that it threads apart, is say you've removed your tail cone, but after the flight, you cannot pull this motor section out, like the whole thing's just stuck in there. Then you can back this body tube section out, and sometimes it'll be really tight, but it'll come out. And then the motor sits right there, and all you have to do is flip it upside down and just give it a little whack, and it just slides right on out. If you ever have an issue getting this phenolic tube out after the motor's removed, if you're wanting to take a look at the phenolic tube to see how it held up, you simply remove your retention point and you can push back here to slide the tube back out if you can't get a good enough hold up here to pull it out. If you're wanting to glue this tube in, it is optional to glue it in. This kit is a no glue kit, so you can fly this entire rocket without ever having put a dab of CA glue on the entire thing for the first flight, and the entire thing will fly wonderfully. Again, I will put out the warning: ensure you check everything in open rocket. Do not trust the flight of a rocket until you have verified its flight in open rocket with the motor you are using. The length of the motor mount tube does limit the size of motor you can put in it. I typically fly H219s or H124s, somewhere in the H or I range, but for RMS, it's pretty much anything that will fit in a 38-240 case will fit in there pretty well perfectly. You do have about another 3 inches, so I think you can get the next case up, but I've mostly flown it on the 240 because that's just what I really like to fly on. Almost all my favorite motors and altitudes are at that range. It also keeps the rockets within visual flight range. As far as how this retention works, so when the motor's in there and the retention goes on the back, it screws in, and then you can see the motor in there, and you can see that the motor doesn't even jiggle inside there. The motor is completely and totally retained. Also, you may notice some light heat marks on the inside of this chamfer back here, but you will not see any true melting. The nozzle never gets that hot. If you have any questions on the build or flight of this rocket, please leave a comment in the description down below or contact me through my website, as I'm always willing to give you a hand as you're getting ready to fly your rocket for the first time, or fly it after it's either had a hard landing or successful landings and you're just wanting to know some more about it. You can easily reach out to me. I've got contact information on my website. So thanks for watching, gang. If you like this video, please consider liking and subscribing. I'll see you all in the next video.